Hi everyone, today we're doing lesson 77a, exponential growth functions. We're going to use exponential functions, equations, tables, graphs to solve problems. So let's talk about exponential growth functions. We've already dealt with exponential functions where y equals a times b to the x, where a is our starting point when x is 0, and our b is our constant factor of change. Now, when we're dealing with exponential growth functions, we're going to use very similar, but it's 1 plus the percentage that we're growing by. So that's our growth percentage. Well, where does this 1 come from? Well, 1, if I wrote it as a percent, is 100%. So if we're growing at a rate of 25% a year, we have the amount we started with plus our additional 25%. So that's where that 1 comes from. And x is how many time periods we're talking about. So let's look at an example. It says the number of mosquitoes at the beginning of summer was 4,000. So that sounds like my starting point. That sounds like my A in this equation. So it says the mosquitoes are expected to grow at a rate of 25% per month. I don't know why my mouse wants to be. That's because I'm holding it upside down. That's how much it's changing every month, 25%. And we want to know how many mosquitoes there'll be after 4 months. So that's my time period, is 4 months. So my y, or my how many mosquitoes I'm going to have, is equal to my starting point, which is 4,000, times 1 plus my growth percentage, and 25% written as a decimal, if I back it up, is 0.25. And since this is months, and we're talking 4 months, my time period's 4. Now, you will need a calculator today. I don't know if I mentioned that before, but you will want a calculator. So I add 1 plus 0.25 and I get 1.25. I raise that to the 4th power. I get 2.4414, blah, blah, blah. So I'm going to do y equals 4,000 times 1.25 to the 4th power, which is that 2.44 number. Just type that whole thing in your calculator. Don't round until you get to your final answer. So I multiply that by 4,000, and I get 9,765.625. Now, because we're talking about a number of mosquitoes, it doesn't really make sense to have all this decimal point, the 625 thousandths. Instead, let's round it to the nearest whole number, which is 9,766. Because we don't have parts of mosquitoes. Maybe they're unhatched ones. I don't know. But I would round it to a whole number. So approximately 9,766 mosquitoes after 4 months. Okay, let's look at our next example. It says your room is too cold, so you decide to adjust the thermostat. The current temperature is 60 degrees. That sounds like my starting point. Oops. Of course, I forgot to hit my pen. So my starting point is 60 degrees. It says it's going to increase temperature by 10% every hour. So 1 plus my 10%, which is 0.10, 0.1, every hour. It's important that we make sure we're talking hours here and hours here. So we want to know how long after, what the temperature will be after 3 hours. So it's going to be y equals 60 times 1.1 or 1.10 to the third power. Again, I just typed that whole thing in my calculator. And I get 79.86 degrees. Will be my temperature after 3 hours. That's pretty warm. But you could round that to 80 degrees. Let's look at my next example. It says, 20 years ago, Mr. Hoslag purchased a home for $160,000. Since then, the value of the home has increased about 3% per year. How much is it worth today? Well, we originally purchased it for $160,000. That sounds like my starting point, or A. It's increasing at a rate of 3%. 3% is 0.03 or 0.03. Either way is fine to write it. And what's our time period? Well, it says he purchased it 20 years ago, and it's increasing 3% per year. So 20 time periods. 160,000 times 1.03 to the 20th power will give me $288,977 and approximately 80 cents. You could probably round that to 288,978. You could probably even round it to 289,000. Depends on what they say to use for your rounding. This one kind of grosses me out. It says the foundation of your house has 1,200 termites. Yuck. Those are gross looking. The number of termites grow at about 2.5% each, 2.4% each day. How many termites will there be after 2 weeks? Okay, so it sounds like we're starting with 1,200 termites, which sounds like way more than I ever want to have. And we know we're growing at a rate of 2.4%. Well, if I back that up twice, that'll be 0.024. But what's my time period? It says 2 weeks, so is it 2? Well, this is where it's important to pay attention. It says 2.4% each day. So how many days are in 2 weeks? You have to match my time periods. This is 14 time periods because it's growing at 2.4% each day. So if this is days, this has to be days. And 2 weeks is 14 days. So let's find how many termites we have now. They take 1,200 times 1.024 to the 14th power. Well, it's not as bad as I was afraid, but still after 2 weeks, I have 1,672.56-ish termites. I would probably round out 1,673. Still way more termites than I would want. Okay, this one is a little bit different. It says we're putting $500 in our, oops, I didn't want to do that. Putting $500 in our bank account that makes 5% interest compounded annually. How many years will it take? So in this case, we're trying to find our X. We want to know our time periods. How many years will it take for our money to double? We know where we're going. We know we want it to double. Well, if I double 500, that's 1,000. So we want to know how long it will take for that $500 to grow to be 1,000. So my starting point is 500. I know my interest rate is 5%, so 1 plus 0.05, but I'm trying to find this x. Well, when you get into higher level math classes, you're going to have a method for solving that. But for now, we have to do some guess and check. So let's think about it. If I said 10 years, let's see where that falls. If I do 500 times 1.05 to the power of 10, that gets me $814. Not enough, because that's not 1,000. So I did pretty good, but it needs to be bigger. So how much further should I go up? How about to 12? 12 gets me almost to 900, but I'm still not enough. Let's jump up to 14. I'm just going up by twos. So 1,000 times 1.05 to the 14th power. Oh, that's getting me really close. 14 equals 197. Ooh, hold it. I think I did something wrong. I did 1,000. That was wrong. I wanted 500. I'm already jumping ahead because I'm like, wait, that's more than I wanted. 989. That's what I meant. 989.97, which is really close. But have I doubled it? I haven't doubled it yet. So if I'm saying I want it at least doubled, I need a little bit more. But I probably don't want to go up too much. This was 14 years. So let's try 15. So 500 times 1.05 to the 15th power will get me $1,039.46. So I can't say that it doubled in 14 years. It has more than doubled in 15. So it's somewhere between there. But if it was how many years till it's doubled, I'm going to have to say 15 because it hasn't quite doubled in 14 years. Like I said, when you get into higher level math, you'll have a method to actually come up with a more precise number for that. Okay, let's find the percent of growth in this function. If I have 1.25, well, this is, remember what's in that percent is 1 plus my percent growth, which is in this case 0.25. Well, 0.25 is my decimal. So if I move it, that is 25% for my growth percent. So that would be D. Let's look at the next one. I have 1.065. That would be 1 plus 0.065 for my growth percentage. Move it. 6.5% growth. C would be the correct answer. So that's it. Have a great day. Talk to you soon.